Okay, so in the word rationalize the denominator, you see the word rationalize. I'm sorry, rational, right? See the word rational. So think of what a rational number is. So remember, a rational number, and we've had the discussion in the past, a rational number is a number that can be written as a fraction, a over b, where the numerator and the denominator are integers. They are integers, kind of like negative 5 over 7. Is negative 5/7 a rational number? Yes, because the numerator is an integer and the denominator is an integer. But keep in mind, though, we can never divide by what number? 0. So b cannot equal 0. So b can be any integer but 0, because we cannot divide by 0. Remember, that's undefined. So a rational number is any number that can be written in that form, where the numerator and the denominator are integers. So kind of like the square root of 25. Is the square root of 25 rational or irrational? It's rational. It's a rational number because I can write the square root of 25 as what number? 5, and I can write 5 as 5 divided by 1. And is 5 and 1 integers? Yes, they're integers. But that worksheet that you turned in, this one here, are these rational or irrational numbers? Those are irrational. So the square root of 17, is that a rational or irrational number? It's irrational because there's no way you can write the square root of 17 as a fraction that's an integer divided by an integer. The square root of 17 is not a rational number. Okay, so just like the square root of 8, the square root of 8 is not a rational number. You cannot write the square root of 8 as an integer divided by an integer. So when we rationalize, in these problems, when we rationalize the denominator, what that means is you want to make the denominator a rational number. That's what that means. Make the denominator a rational number. That's what that means. So make the denominator a rational number. So the directions of the phrase rationalize the denominator means you want the denominator to be what kind of number? A rational number. So we're going to look at two easy problems, and then we're going to look at ones that's a little bit more complicated. All right, the first one. So the directions are rationalize the denominator. Rationalize the denominator. And simplify. All right, so rationalize the denominator and simplify. Okay, number 1. Suppose I had 5 divided by the square root of 3. 5 divided by the square root of 3. Okay? Now, first of all, is 5 divided by the square root of 3 rational or irrational? It's irrational. The reason it's irrational because it contains an irrational component to it, the square root of 3. You may say, well, 5 is a rational number. I agree, 5 is a rational number, but a rational number divided by an irrational number is still what kind of number? Irrational. Okay? But what are the directions? What do directions tell us to do? Rationalize the denominator. So look at your denominator. What is the denominator here? Square root of 3. The square root of 3 is what kind of number?
5.
The square root of 3 is what kind of number? Irrational. Square root of 3 is an irrational number. I want to make the denominator what kind of number? A rational number. Okay? So listen carefully. I have 5 divided by the square root of 3, and I want to make it equal to some number where the denominator is what kind of number? Rational. That's what I will end up with. I want to do something to this fraction right here. I want to do something to this fraction so that way I end up with what kind of denominator? Rational. All right, now I want to remind you of some properties you used many semesters ago, and every semester you used it. And that was this idea. If I have, so this is a review, if I have 6 divided by, let's say, 7, and I want to write some equivalent fractions. Equivalent fractions. Okay? Equivalent fractions. So in other words, do y'all agree that 6 divided by 7 is the same thing as saying 12 divided by 14? Y'all agree? So 6/7 is equivalent to 12/14. Basically what I did was I multiplied both numerator and denominator by what number? 2. So I got 12 divided by 14. So what I did to the denominator, or what I did to the numerator, I also did to the other part. Do y'all agree that 6/7 is also equivalent to 18 divided by 21? To get 18 divided by 21, to get this equivalent fraction, what did I multiply both numerator and denominator by? 3. So 6/7 times 3 divided by 3 is 18 divided by 21. Okay, so you understand what I mean by equivalent fractions? All right. So if I go here now, I want to write an equivalent fraction. But I want the denominator to be what kind of number? Rational. All right, now listen carefully. How many terms do you see in the denominator? 1. Whenever it's just one term, that's the easy kind. All right, now we're going to remember some things. What is the square root of 6 times the square root of 6? That's another review. And it's not the square root of 12. It's square root of 36. Which is what? 6. Right? Now, I want you to notice a pattern. What's the square root of 7 times the square root of 7?
49.
I say I'm not wanting you to go there, but that's fine. Square root of 49. But what's the answer? 7. The square root of 2.6 times the square root of 2.6, you better tell me is what? 2.6. Okay? Now remember, you've learned in the previous lesson this idea. I want you to remind you about this. So these are all things that are needed to understand what's going on here. So in a previous lesson, you learned that the square root of x to the 8th power is x to what? To the 4th. You said 8 divided by what? 2, right? So the square root of x to the 8th is the square root of x to the 8 divided by 2. Remember that property? Which is x to the 4th. So if I look at the square root of 7 to the square root of 7, what I want you to say was that was just 7. Because in your mind, do you agree that's the square root of 7 squared? 7 times, and then what's 2 divided by 2? It's just 1, right? So you get 7. So I specifically put a decimal here because I wanted to see how many of you would use your calculator to figure out what 2.6 times 2.6 is. So I didn't want you to do that. I want you to realize that the square root of 2.6 times the square root of 2.6 is the square root of 2.6 squared, right? And then that's 2.6 raised to the 2 divided by 2. And what's 2 divided by 2? 1. Okay, now, based on what we just talked about, see this right here? Based on what we just talked about, the square root of 6, just the square root of 6, right here, is what kind of number? What kind of number? It's an irrational number. 6 is what kind of number? Rational. Okay. So, when I write an equivalent fraction, when I get to this point right here, what do you think I need to multiply numerator and denominator by to get this to be a rational number?
3.
Not 3. Square root of 3. The square root of 3, not 3. Because if you say 3, the square root of 3 times 3 is not 3. It's 3 square root of 3. So the square root of 3. So basically, here's the idea. When the denominator is just one term, you just multiply both numerator and denominator by that denominator. And now you're going to write it as one fraction. What's 5 times the square root of 3? 5 square root of 3. What's the square root of square root of 3? It's just what? 3. And there's your answer. So you get 5 square root of 3 divided by 3. And what kind of number is this denominator now? 3 is a rational number. So 5 divided by the square root of 3 is equivalent to what fraction with the denominator 3? 5 square root of 3? Where 3 is now a rational number. So this and this are the same thing. Now, don't make the mistake and do this. I'm going to ask you this off to the side. Let me go off to a new page. And we're going to ask you this. If I had 5 times 3 divided by 3, could I reduce these 3's?
Yes.
Yes. 3 into 3 is 1. 3 into 3 is 1. Because these are all factors. So I get 5 divided by 1, which is 5, right? Okay. I'm going to ask you this. I have 5 square root of 3 divided by 3. Can I say this? 3 into 3 is 1. 3 into 3 is 1. No. Because that is not a 3. That's the square root of 3. This is not correct. The square root of 3 is not 3. Because if you made that mistake, what's the square root of 1? 1. Basically, you're saying this is 3. And it's not. It's the square root of 3. So you cannot do that, okay? The square root of 3 is if you use your calculator, it's about 1 point something. All right, so this is your answer. You're done. Okay, now let's look at number 2. So with all that discussion, you should now be able to do number 2. Number 2. So in number 2, let me go ahead and find a new sheet. In number 2, you have negative 15 divided by the square root of 10. Negative 15 divided by the square root of 10. Again, the direction says to do what? Rationalize the denominator. Okay, now, if I'm going to, now notice the square root of 10 is rational or irrational? It's irrational. So right now my denominator is irrational. I want to make it what kind of denominator? Rational. So I want to find out what this fraction is equivalent to with a denominator that's rational. So let's think about this. What do I need to multiply? Now remember, there's one term in the denominator. So what do I need to multiply both numerator and denominator by to get a rational denominator? Square root of 10. And so when I do that, and I write as one fraction, I get negative 15 square root of 10 divided by what? 10. Square root of 10 times the square root of 10 is 10. Now remember the direction set to simplify? What can I simplify here? negative 15 and the 10, because what factor they both have in common? 5. So when I look at this, right, I'm going to just write it right here. 5 into 10 is 2. 5 into negative 15 is a negative 3. So what's the answer? Over 2. So I get negative 3 square root of 10 divided by 2. So now notice my denominator is now what kind of number? A rational number. This is still an irrational number, but the denominator is what kind of number? Rational. So if I go back to the original problem, negative 15 is what kind of number? Rational. The square root of 10 is what kind of number? Irrational. I want to make the denominator what kind of number? Rational. And so what happens in the end is that the numerator now becomes what kind of number? Irrational. The denominator now becomes rational. So mathematically, we tend to not want a square root in the denominator. So that's why we rationalize the denominator. All right, now let's look at number 3. So what's going to happen number 3 is this now. We have 2 divided by 3 minus the square root of 2. 2 divided by 3 minus the square root of 2. So what kind of denominator do I have? Rational or irrational?
Irrational.
It's irrational because I have a square root of 2 in there, which is irrational. So I want to make this denominator rational. So you have any ideas what you can do? Multiply numerator and denominator by what? Square root of 2. All right. So what he's doing is he's using the idea we did a while ago, right? He saw in number 1 that the denominator was the square root of 3, and all we did to rationalize was multiply numerator and denominator by the square root of 3. The same thing when we did the square root of 10. We multiplied both numerator and denominator with the square root of 10. Okay? Now, what he's seeing here is he sees the square root of 2. And so what he wants to do is he wants to multiply both numerator and denominator with the square root of 2. What's going on? All right, so that's fine. But I want to continue with this. So he realizes that what he said was incorrect. And I want to show you why. So if you multiply both numerator and denominator by the square root of 2, that's not going to help you. So he thought about it, and then he realized it wasn't going to happen. Because what happens is this now. The numerator is 2 square root of 2, right? The denominator is the square root of 2 times this whole thing right here. Meaning this, the square root of 2 times 3 minus the square root of 2. And so if I get rid of the parentheses by distributing, I get this. I get 2 square root of 2 divided by 3 square root of 2. And what's the square root of 2 times the negative square root of 2? Negative 2 though, right? Negative 2. This is still what kind of denominator? Irrational. So that did not help. That did not help at all. So let's get to the point where you know what to do. Okay. So I want you to remember something. So let's kind of review this. If I have 2x minus 3 times 2x plus 3. There was something special about that. What did that look like? In terms of factoring, what did that look like?
Square root of 2.
The difference of 2 squares. The difference of 2 squares. And so when you follow this, what did you notice for the outer and the inner? When you added them up, what did you get? Okay, so let's go ahead and do this. What is 2x times 3? You're really telling me that 2x times 3 is 4x squared. Is that what you're telling me?
6x.
What is the outer? 6x. What is the inner? negative 2x, negative 6x. So when you add them up, you get 0, right? Okay? And so when you FOIL this, what's 2x times 2x? 4x squared. The out and the inner cancel out. You get 0 as a sum. And then what's the last? What's negative 3 times a positive 3? Negative 9. And remember, this was the difference of two squares. So you end up with two terms, not a trinomial. Okay? All right. Now, I want you to notice something. The first terms are exactly alike, right? 2x, 2x. The last terms, they are what to each other? What's that word?
Opposite.
Opposites. They are opposites. So whenever that's the case, the outer and the inner, when you add them up, will become 0. The sum will be 0. Okay? So, let's look at this. Let's multiply this. 2 minus the square root of 7 times 2 plus the square root of 7. 2 minus the square root of 7 times 2 plus the square root of 7. Doesn't it kind of look like the difference of two squares? The 2's are alike. What do you notice about the square root of 7's that you see here?
Yeah.
They're opposites. So if I FOIL this, because I have two binomials, if I FOIL this, what's 2 times 2? 4. What's the outer and the inner? First of all, what's the outer? 2 square root of 7. What's the inner? Negative 2 square root of 7. When I add them up, you get 0, right? That's what you better get, 0, when you add them up. Now, look at the last. A negative square root of 7 times a positive square root of 7. You get a negative what? Come on, I don't want you to. It is square root of 49, but you got to say what real quick?
Negative
7. So negative 7. And so it's 4 minus 7?
Negative 3.
Negative 3. Okay? All right, now, notice this 2 minus the square root of 7, it was what kind of number? Irrational. I multiplied this 2 minus the square root of 7 times, not its opposite, because the opposite of 2 minus the square root of 7 would be negative 2 plus the square root of 7. Remember that? So we are going to call it opposite. But I did multiply by a binomial where the first term was still the same, but the last term was the opposite of the first of this term here. And I ended up with what kind of number? Rational number. So that takes us to this idea, the word conjugate. Okay, so listen carefully. Conjugate. So let's talk about conjugate now. By definition, the conjugate, C-O-N-J-U-G-A-T-E, the conjugate of this irrational number, and let me just go ahead and use some letters right now. The conjugate of A plus the square root of B, the conjugate of A plus the square root of B, all you do to find the conjugate is just change the middle sign, basically. So you're taking the opposite of that second term. So the conjugate of A plus BI is A what? I'm sorry, not BI, the square root of B. The conjugate of A plus the square root of B is A what? Minus the square root of B. Okay? So the conjugate of 2 minus the square root of 10 is what? 2 plus the square root of 10. So all you do is just change the sign of that second term. You understand? We're not taking the opposite, because the opposite of, just make sure you remember this, the opposite of 2 minus the square root of 10 is what? Negative 2, what else? Plus the square root of 10. All right, so don't confuse the words conjugate with opposite. Those are two different things. So the conjugate of negative 6 minus the square root of 2 is what? No, you're taking the opposite. Negative 6 plus the square root of 2. So the first term stays the same. If you change them all, now you're dealing with opposites, and they're no longer conjugates. They're just opposites now. So that's the idea of conjugate. Now let's go back to that problem we've been working on now. So that's number 3. So remember number 3, we had this. So remember number 3, a suggestion was to multiply both numerator and denominator square root of 2, and you notice that didn't work because you still ended up with an irrational number. So now, with all this discussion, you should now know how, you should now know, I keep messing this up. You should now know what I need to multiply numerator and denominator by to make this a rational number. So in other words, you're going to multiply, whenever you have a binomial, you're going to multiply numerator and denominator by its what? Conjugate. So it's a conjugate of 3 minus the square root of 2. Just like this. All right. So let's talk about this in terms of points on a test. So this would be 10 points, let's say, this problem. You would get 1 point just by doing that. All right, now you need how many more points, though? You want to get the other 9 points, right? All right, so here's the next thing you want to do. So remember when we did that very first problem, when we had this right here, we wrote as 1 fraction? That's what you want to do. You want to write this as 1 fraction. So you see you're multiplying 2 fractions? Put as 1 fraction. All right, so in other words, you're going to write like this now. So you're going to say, all right, so this is going to be 2 times this whole numerator right here. So we 2 in parentheses, 3 plus the square root of 2, divided by, and then you're multiplying these 2 binomials. Put those in parentheses. 3 minus the square root of 2 times 3 plus the square root of 2. So that will be another 1 or 2 points right there. Now, based on your previous experience, what do you think would be the next thing you want to do? Okay, so I heard distribute. So in other words, you're trying to get rid of the parentheses, correct? So in the numerator, what property are you going to use to get rid of the parentheses? The distributive property. And what are you going to do to get rid of these parentheses in the denominator? What's that method called? FOIL. So in the numerator, what's 2 times 3? 6. Plus, what's 2 square root of 2? 2 square root of 2. Good. I'm glad you didn't say the square root of 4. Because in order for this to be the square root of 4, this should have been the square root of 2 times the square root of 2 is what? Square root of 4. But that's not the square root of 2. That's 2. So 2 times the square root of 2 is just 2 square root of 2. All right, now let's talk about the denominator. So I have 2 binomials. You're multiplying, so use the FOIL method. But what do you notice about these 2 binomials? Those are called what? Conjugates. So when you FOIL them, what happens to the outer and the inner when you add them up? You get 0, right? So basically all you really need to look like in terms of the FOIL is the first and the last. But we can go through the FOIL. What's 3 times 3? 9. Okay? So let me go off to the side first and just rewrite this over. You get 3 minus the square root of 2 times 3 plus the square root of 2. So 3 times 3 is 9. Now here's what I want you to think about. The outer and the inner, you don't have to write anything down. Because you know these are conjugates, and you know that when you add them up, the outer and the inner, you're going to get what number? 0. But you can check it. Look, 3 square root of 2 is 3 square root of 2, correct? A negative square root of 2 times 3 is a negative 3 square root of 2. When you add them up, those are opposites. You get 0. Now, look at the last now. You get right here, you get a negative square root of 2 times a positive square root of 2. Guys, what is this? Negative what? Negative 2. The square root of 4, which is 2. So that's 9 minus what? 2. So that's 9 minus 2. So now I have 6 plus 2 square root of 2, all divided by what? 7. And you cannot simplify anything. No. So there's your answer. So you got your 10 points. So did I end up with a fraction that had a rational denominator? Yes. Okay. So when you have two terms, you now know that you're going to have to multiply both numerator and denominator by the conjugate of the denominator. All right, let's go to number 4. Number 4. So let's suppose you had this. Let's suppose you had 2 divided by 3 minus the square root of 5. 2. I'm sorry. Let me change it to this one because I'm trying to use the one I used in the last class. Let me change it to negative 5 divided by 2 plus the square root of 6. Change it to that one. Okay, I want to rationalize the denominator. So right now my denominator is what kind of number? Irrational. How many terms do you see? 2. You now know that to make this binomial a rational number, I am going to have to use its what? Conjugate. And what is the conjugate of 2 plus the square root of 6? 2 minus the square root of 6. So first thing you're going to do is going to say, you can multiply both numerator and denominator by 2 minus the square root of 6. Okay, now what's the next step? That's right, as one fraction. So you're going to say negative 5 times 2 minus the square root of 6 divided by, in parentheses, 2 plus the square root of 6 times 2 minus the square root of 6. And now you get rid of the parentheses. So the numerator you can distribute. So what's negative 5 times 2? Negative 10. What's a negative 5 times a negative square root of 6? A positive 5 square root of 6. Divided by, all right, let's talk about the denominator. So let me just go ahead and rewrite this right here, and let's kind of talk about it. So I'm going to use the fall method. These are conjugates. So that means that the outer and the inner, when you add them up, become what? 0. And it kind of makes sense because the outer is a negative 2 square root of 6, and I'm adding it to the inner, which is a positive 2 square root of 6, and I get 0. So all you're left with then is the first and the last. What's 2 times 2? 4. All right, now let's talk about the last. I have square root of 6 times a negative square root of 6. What does that equal to real quick? Negative 6. So that's 4 minus 6. So what's the denominator? So I get negative 10 plus 5 square root of 6, all divided by what? Negative 2. Can I simplify anything? Look, huh? Okay, so I'm glad you brought that up because many students, they do this. So I'm going to go ahead and rewrite this. And so what I've noticed that she did, and I think you did on your test, was she did this. She said, all right, I have this right here, and so I can reduce the negative 10 and the negative 2. And we've had that discussion many times about this situation. And so what some students do is they do this. They'll say negative 2 into negative 2 is a negative 1, and then 2 into negative 10 is negative 5. And so then they say this. They'll write it as negative 5 plus 5 squared is 6, all divided by negative 1. First of all, is that correct? No. Because not only is negative 2 being divided into negative 10, but negative 2 is also being divided into what? 5 squared is 6. So you cannot do that. That is mathematically incorrect. Now, what you could have done, which we did, you've learned already how to do, is you could have broken this down to two fractions if you wanted to. So in other words, you could have said negative 10 divided by what? Negative 2. Plus 5 squared is 6 divided by what? Negative 2. And then you can reduce this. Then this becomes what right here?
Negative 5.
No, not negative 5.
Just 5.
Positive 5. And then a positive divided by negative is a what? Negative 5 squared is 6 over 2. But I would not have gone that far. I would have just left it like this. So just leave it like this. So if you want to go further, though, you can say this or you can say this. Okay? But this is the preferable way of writing it. Just leave it as that one fraction. Don't break it down to two fractions. Leave it as one fraction. Okay? All right, let's look at one more with this. So this is going to be number 5. So number 5, you have 3 divided by the square root of 7 minus 2. 3 divided by the square root of 7 minus 2. The denominator is irrational. What are you going to do? Multiply both numerator and denominator by the conjugate. What's the conjugate of the square root of 7 minus 2? Okay, square root of 7 plus 2, that's fine. And now rise one fraction, so that's 3 times the square root of 7 plus 2 divided by the square root of 7 minus 2 times the square root of 7 plus 2. So write that next. So if we do that, you get an extra point or 2. Now I'll get rid of the parentheses. So we're going to distribute the numerator. So when I distribute the 3, I get 3 times the square root of 7 plus what? 6. All right, let's talk about the denominator. The denominator, those are conjugates. So the outer and inner cancel out. They add it to be 0. So what's the square root of 7 square root of 7? 7. What's the negative 2 times the positive 2? Negative 4. So what's the denominator? 3. So you get 3 square root of 7 plus 6, all divided by what? 3. All right, now if you want, you'll get most of your points, but go further. Because look, remember how we circled in previous problems? We circled the coefficient of the radical, we circled the 6, and we circled the denominator. What do those three things that have circled have in common in terms of a common factor? They're all divisible by 3. So if I look at it again with that idea in mind, 3 into 3 is 1, 3 into 6 is 2, 3 into 3 is 1. So what are going to be your answer you're going to write? Square root of 7 plus 2. Don't say divide by 1 because you know that square root of 7 plus 2 divided by 1 is still the square root of 7 plus 2. Now if you want to put the 2 first, you can. So you could have said R2 what? Plus square root of 7. It does not matter. Okay? All right. So that's the end of that part. So that should give you enough idea on how to rationalize the denominator.